So welcome everyone to our Lunch and Learn webinar for August. It's not so hot here today, but apparently this topic is because we have quite a lot of interest in it. And I want to get right to it, but just some Zoom etiquette. Everyone should be muted as you join the webinar, and I'm going to just ask that you stay on mute until the end, and I can open it up for questions. There's also a Q&A and a chat function at the bottom of your screens, which I'll keep an eye on during the presentation, so feel free to put your questions and comments in there when you think of them. We are recording this session, and the link to the recording and the slide presentation will be provided to everyone who signed up for the webinar and our NEBR members. So thanks for joining us today to hear from the last of our 3 Shark Tank participants from our annual conference last year. And unlike the other 2 Shark Tank tankers, the Ctec Energy USA is actually based in New England. Our presenters today are Chris Harrison and Peter Wild. And I'll start with an intro for Chris Harrison. He's the CEO of Ctec Energy USA. He has over 40 years of experience in sales, marketing, strategy, and leadership in the media, publishing, waste, energy, and consulting businesses. He's worked for a variety of firms, but most notably, he served as Executive Vice President of Sales and Marketing at Oak Leaf Waste Management, LLC. And he was part of the executive team that propelled that company to become one of the fastest growing waste management companies in North America before it was sold to Waste Management. Mr. Harrison graduated from Marist College in 1982 and spent 1 year abroad at Harris Manchester College in Oxford. Peter Wild is the inventor of the technology you're going to learn about. He has an extensive and eclectic professional background. He was born into a successful family-owned agricultural, poultry, and livestock farming business. And after graduating with a degree in finance and accounting, he started work in the banking world. While he was with Westpac Banking Corp., he oversaw the development and implementation of their cash point and electronic banking systems and services. He used his data information engineering and programming skills to develop the bank's satellite processing of these electronic point of sale and ATM networking activities. He became the co-owner of an Australian merchant banking group, and he was heavily involved in the bank's implementation of new technology and also trading and property development, commercial and residential. He became the founder and 91% owner of a glass processing company, which became huge before it was sold in June 2020 rather. He's a recognized expert and market professional in a wide range of industries, including livestock, cropping, mining, textiles, pharmaceuticals, chemicals, commodity trading, capital raising, mergers and acquisitions, IPOs, property development, the list goes on. He is also a qualified data information engineer and an accountant. So this will be a little bit of a different format today because these guys don't have slides per se, but this will be very interesting, and we are planning to leave lots of time for questions because there will be lots of questions. So with that, I will tag Chris and or Peter to take it from there.
Okay, let me say hello. Good afternoon, everyone. Janine, thank you for inviting us. Peter and I are the principals in this enterprise here, and we have the exclusive rights to manufacture, market, and sell Ctec technology here and in other places around the world, actually. I'm going to give a brief overview of the technology just so that everybody, and I think many of you have probably heard this at different times elsewhere previously, but basically Ctec is our technology, which stands for Clean Thermodynamic Energy Conversion. That is our process. We're a clean thermodynamic energy conversion process. We happen to use pyrolysis and gasification in our system, but it is not just a gasification pyrolysis system. There's a lot of other things that go on within this technology, and it's patented, and it's been around for a while, successfully implemented in the UK and in the EU. The company was founded in 2010 by Mike Burns. Janine, you said Peter was the creator of the technology. Actually, Mike Burns was in the automotive industry for about 30 years as a major engineer worked for Ford. Ricardo was chief engineer at Daewoo Motor Corporation, and is recognized as a global thermodynamic expert when it comes to this technology. So Mike, when he was in the automotive business, observed that there was a lot of heat coming off engines going into the atmosphere. Everybody was looking at it as a cost. He felt that there was an opportunity, financial opportunity. So when he retired in 2010, formed Ctec, spent 6 years of heavy research and development, forged patents, etc., formed, created the successful plants that we have now. And for the last 7 years, we now have over 40 plants in England, France, Germany, Czech Republic, and Italy successfully deployed with no problems, handling all sorts of waste streams, including sludge. While we don't have a plant that's specifically, tied up right next to a wastewater treatment plant, we have sludge being brought in at different plants and being destroyed there thermally with no emissions and creating clean energy. So ultimately, what this technology does, it creates, it thermally destroys waste. Now, as long as the waste lived, that's fine. If it won't do metal, it won't do glass, it won't do, asbestos or concrete, but it's not designed to. Anything that was biological that lived, we can do. So it's food waste, sludge, plastic, chips, wood chips, MSW, certainly medical waste, chemical waste. We can even do hazardous waste at 1400 degrees Celsius, which we max out at. So we can destroy all of the waste streams. We can take those gases and convert them into clean energy and create thermal electricity and hydrogen. And hydrogen can also be used to make green ammonia as well. Now, for example, the first group that we went to in East Sussex, right outside of London, about 60 miles outside of London, New Haven Hospital. They've had us for over 7 years. They've just ordered another plant as well. We handle all their medical and their regular waste. We're just thermally destroying 18 tons a day. We've gotten rid of all of their transportation and disposal costs and the footprint, the carbon footprint that surrounds all those activities. And on top of it, we're creating 20 gigawatts of green thermal that we're using to heat and cool the hospital as a waste product, and also 2.8 gigawatts of electricity that we're using to power a port in the town. The hospital is actually selling it to the port. So no emissions, not pulling from the grid, no chemical, residue or whatever, and the waste is comes out to about 4% of its original body weight. When it's a regular stream, when it's sludge, it's about 8%, but we can destroy all of that with the plasma unit. And ultimately, that's what we do. We destroy waste and we create clean energy. We've been talking to a number of companies in the Northeast, a number of them involved with wastewater treatment, food processing, hospitals and healthcare, just general industry, food, the schools and universities. But the fact that we can do this without creating pollution and destroy all of the PFAS and all the other forever chemicals is put us on the map for people to want to talk to. So I think that's a good brief overview, and I think it would be good to just dive into any questions and answer specifically technology questions, which Peter is ready, willing, and able to handle as they come across. Janine, do you have any questions to start?
Well, I think it might just be helpful to maybe walk through the different process units. So when, if you have a raw material, what are the different stages it goes through? Just so I understand. You mentioned gasification and pyrolysis. What about drying on the front end? What about?
Okay, I'll dive in here now. All right. Nothing new with pyrolysis and gasification. It's been around for 50 years or more, in all sorts of different forms. And just going back a little bit, I got involved with Ctec in the UK originally from a funding point of view, where Mike actually came to a finance company that I own, trying to raise additional capital, and that's how I basically stumbled across Ctec. Now, obviously, from a funding point of view, we see hundreds of applications on a weekly basis from all sorts of technology. So we have a little bit of advantage of being able to weed out the chaff from the wheat, as you will. And this process sort of struck me as being interesting, shall we say. So we did actually commit capital to the company, and then I got even more heavily involved and have assisted in some of the refinements and developments of the entire system. So the purpose of this call is more centered around PFAS, because that seems to be the buzzword at the moment. So and there's a huge requirement from a number of clients and potential clients in the States for processing sludge in particular. Now, Chris has already mentioned the fact that we don't have dedicated plants currently. However, what we've done to process dedicated sludge is we are having to accept wet products, which is something that Janine just mentioned. Now, when I say wet products, and municipal's got 30% moisture in it anyway, and that's easy enough for us to process. But sludge is a whole different animal. So at the front end, we actually have a dedicated drying unit. Now, the unit itself works on an agitator and a cutting type system, and it borrows some of the supercritical heat that the Ctec plants produce to take the moisture content down to 10%. Okay. Now, the moisture that is destroyed or reduced, one way or another, goes through some of our supercritical heat exchangers, which are so heavily patented I can't get into too much detail. I can tell you that there's a few American companies we're lining up to knock out of the ballpark at the moment because they're in breach of patents. However, the water content itself goes through some of our supercritical heat and steam processes and gets fed into a section of the chamber for the reduction of the water content through the manufacture of syngas. So in other words, we don't have wastewater available in a pure Ctec plant running a full tank. Now, the other thing we've had to do is, because it's a completely separate unit, we actually pelletize the sludge at that stage so that it's a more acceptable product into the front end of Ctec. So how Ctec processes or destroys not just PFAS, but we're also talking about any sort of organofluorines, which are obviously PFCs, your polyflouroalkyls, which are your PFAs, your perfluorocarbon octanates, which are your PFOAs, your pyrolysis sulfonics, which are your PFOSs, and then another nasty that people don't seem to talk about is perfluorohexane sulfonic, which is your PFHXSs. And then on top of that, you've got your F gases, your fluorinated gases. Okay, so the Ctec plant can accept solids, liquids, gases, or a combination of those. Okay, so that means sludges, plastics, biomasses, tires, flooring materials, astroturf, you name it. So if it used to live at some stage, which is what Chris said, the Ctec plant can cope with it. So PFAS in particular, which is what we're sort of here for, is one of those really strange substances, because it has chain link carbons. It's a little bit like it has its own DNA. Okay, so you have linked carbons in fluorine atoms. Okay, and that actually makes that carbon fluorine bond one of the strongest bonds, okay, which makes it recalcitrant, and it's not easily to be degraded. And this is the issue the world is facing. We can do it. Now, I'm not about to go into precisely how we do it, but some clues for potentially some of our competitors that might be on this call are: it's a combination of heat, and when it's applied, combined with pressure, MPAs. Okay, that's part of the clue of breaking down that bond. All right. Now, I'm not going to state those temperatures or those pressures, because you spend your own 30 million euro and work it out for yourself. But there are claims that PFAS is typically destroyed at 800 to 900 degrees Celsius. I will state that's not true. The temperature has to be higher than that, and the temperature has to reach at least 1100 degrees Celsius. Okay. Now, there's a few other tricks which I can let you know about. Inside, we have 2 gasification chambers, and we have a plasma unit within our systems. The first gasification chamber is obviously where all the feedstock goes in, irrespective of what that feedstock is. And we have, it comes in at, as an example, it comes in at waist height, and by the time it's processed, it's 20 feet in height. So we have a traveling escalator inside our first chamber, rising up, and material rises. Now, all materials start to be destroyed at different temperatures. Now, as that grid is rising, it's also oscillating and moving from side to side. And that is part of the trick of controlling the production of the syngas itself. Okay, so we use what's in layman's terms, you would call it supercritical combustion without flame, which sounds a little bit strange when you use the word combustion. We have a controlled, I got to be careful here that I don't divulge too much, but we have a controlled detonation technique with a low viscosity combined with high heat transfer, which gives us the ability to produce supercritical water oxidization. Okay. I say okay, and most people are probably shaking their head saying, what the hell is he talking about? But that superheated supercritical water is part of our secret sauce in the manufacture of syngas, which then allows us to then produce hydrogen, which is and our hydrogen that production is at 99.9% purity, so it's extremely high. We then steal half of that hydrogen, run it through our real secret sauce, which is the heat exchanger, to rapidly cool it down to 35 degrees Celsius. That's a figure I don't mind sharing. We then pass that cooling back, oddly enough, into the first chamber. And it's that effect that gives us temperature control along with pressure control to dissipate and destroy PFAS. Okay. Now, as a backup plan, any gases that we've missed get passed into the second chamber, only for 3 seconds, but it's running at 1400 degrees Celsius. And at that stage, there is literally nothing left. Now, as part of gasification, there is always a residual ash. So 100% product goes in, we will get between 4 to 8% of ash coming out. Now, we do actually mine that ash, because inside the ash, you wouldn't believe what elements there are. You know, there's coppers, there's thilamines, there's sulfurs, there's dioxins, there's all sorts of things in there. Even trace elements of mercury come out of MSW or a sludge. How it gets in there into sludge, who knows? But it does. So our third insurance policy, if you will, is our plasma unit, which is again manufactured and designed by Ctec, and that runs at 5000 degrees Celsius. So by that stage, there is literally nothing left. Now, a few other things I can tell you that might be of interest, and just bear with me. Just gathering my thoughts as to how far I go. Within our heat exchanger, we have 10 different steam heat temperature control units. Because there is an absolute critical point when it comes to recirculating exhaust gases, which are pushed back into the first gasification chamber. This is probably starting to get way too technical.
Yes.
But those exhaust gases are coming in at a controlled temperature of just under 400 degrees Celsius. Now, this comes back to part of the reason why the plant doesn't require any external energy, with the exception of the very first time it started. Okay, so to fire up our plants on day one, we need about 200 kilograms of propane to fire the system up for the very first time. Once it's been turned on, even if it's shut down for 5 days maintenance because something has gone absolutely disastrously wrong, we don't need any other energy source. It's all stored internally to get back into operation. So part of the process to destroy PFAS is using a controlled oxidant supply. Okay, so and the control of that assists in the generation of supercritical water through thermal converters, and that's important because gasification at no stage burns. I mean, we've got to make that extremely clear. In some jurisdictions, we get thrown under combustion legislation, and it's an absolute fallacy. You will never ever see a flame in a proper gasification unit, and I do use the word proper fairly loosely because there's a lot of gasifications out there. Outside of that, I'm not sure whether I want to say too much. I would rather handle questions and say yes, no, maybe. I'm sorry, I can't tell you.
Yeah, there was a question.
Sure. Yeah,
But
no,
it's
this,
not just PFAS, okay?
Yes,
It's carbon monoxide, it's carbon dioxide, it's all the hydrocarbon derivatives are all destroyed and recorded. Now that's important. Our system actually, we can't record what's coming in because we have no control over that. But we can certainly control and report what is coming out. So the system, and unfortunately, there's no credit claims available for PFAS at the moment, which is a real shame. But we do report, record, and claim for all of the ERFs, carbon monoxide particle matters, SOs, and stuff like that. We're just hopeful, because PFAS is such an issue, one day we might get paid to destroy it.
so there are already some questions coming in if you want to
yeah,
just dig
there was a
into it. And
question
Chris,
earlier
did
that
you?
was, it was saying there was a question that was there earlier that was pulled.
No,
Someone
I typed the answer to it because I thought maybe you could, do you have like a basic outline of a process that you could show? We've got a lot of engineers on here. They like that
yeah,
stuff. But let
Peter,
me get to some of the questions while
okay,
you guys think about that. And I saw Paul had his hand up. I don't know where that went, but I'll get to you, Paul. Here's a question about how does the fuel source enter the system? Conveyor belt, front end loader.
Okay, obviously it depends on the waste system. With sludge, if that's what we want to talk about, we've got two options there. We can either receive it by pipe, and just to let you guys know that our pipeline, our receiving pipeline, has monitors in it checking the moisture levels and also checking the volumes. The reason we check the moisture levels is that that's important information for our drying units. Some sludge is 20% moisture, some's 28, but we're set up to catch the guys that try to send us the 3% solids instead of processing it through their own waste system. So that's one method. Now that sludge or slurry goes straight into the drying unit. If we were lucky enough to receive even drier sludge, then it is possible it could go to the front end of the Ctec plant, where it would be blended with whatever other waste stream just in the feed hopper unit.
All right.
So
Some
we
good
can
questions
take a
coming in.
tanker, we can take a tanker and stick it in a tank and handle it ourselves, if that's the case, or we can receive it by pipe.
Okay, so some options there. All right, Noel has an excellent question. Is the intent of the system to be owned and operated by the company, or will the system be able to be purchased by a utility and operated by their staff?
We have options there. We're quite happy to sell a plant. We're quite happy to owner operator. We're quite happy to joint venture. Makes no odds. I mean, every client has a different requirement. We're set up to, and they can even lease. The only thing with our plants is that, and we are absolutely adamant about this, with the sale of a plant, there is a mandatory, compulsory, there's not enough words for me to explain it, at least 20-year compulsory maintenance contract, okay? Now, that maintenance contract is on a fixed non-CPI price over the life of the plant, which is going to be 30 years, but for contracts, 20-year contracts. Now, that maintenance contract includes all the monitoring, which is 24/7 with our own engineers. Okay? It includes all of the parts, all of the labor, the IP. It includes absolutely everything. Now, the reason it can include the parts, we are well aware in 6 months, a particular seal might look like it's going to need replacing. Okay, so we replace it. We know at 5 years we need to replace part of the hydraulic on the feed because we've got robotic feed as well. Okay, we know the timelines of when our parts may or may not fail, and we don't take risks, we just replace. Okay, so over 20 years we know what our entire cost is going to be. We've broken it down to an annual fee so that it doesn't hurt.
Thank you. That was a good question. And it raised another question for me, and I can't believe no one's asked this yet, but what's the cost of a unit? Can you give us a ballpark?
Yeah, we can. A unit with the hydrogen attached, with the ability to process municipal and sludge at, okay, let's go back. A standalone unit, $10 million. Okay.
Okay. Yep.
But it's volume dependent. So if we're talking about the plant's capacity, because this is important, if we're processing medical, okay, 18 tons a day, 100% medical. If we're processing municipal, a recycled municipal, we don't want steel or concrete, okay, 18 tons a day. If we're processing other products, we have what we call a recipe, okay, because gasification works on BTU or kgcal units, all right? And we have a specific BTU value that for us is optimum. So we could not process 100% plastics. Okay, the plant won't take it. We can only process 75% plastics, and we would have to add another waste stream, whether it be municipal or biomass of some sort. Okay, if we were processing tires, as an example, 50% of our feed could only be tires, and we would have to add another waste stream. That could be sludge, that could be plastic, that could be municipal, it could be something else. Okay, because obviously inside tires it's full of oil derived products, right? And the BT units become way too high, and the destruction of the chemical compositions become too tight. One of our key and primary secrets is the size of our gasification plant. Okay, it is the size it is because it works. Right now, I don't want to go and talk too much about competitors out there in the industry and the size of the gasification plant, but we are well aware of their shortcomings without getting too rude. We're well aware of, there's a classic example. There was a huge plant built down in Florida, massive gasification plant, and it failed. And it got sold several, it went into bankruptcy or liquidation. It got bought by another outfit that tried to make it work. It's never going to happen. And the reason is really simple. It's the size of the gasification unit. You can't control oxidization and the change of chemical compositions properly to make it work. But, so a standalone unit is 10 million. If we're talking sludge and the capacity of sludge, that's a whole different animal. The unit itself can still only process 18 metric ton a day, not short ton, metric ton a day, but we're receiving sludge in a wet form. Okay, so the Ctec plant can process, in sludge terms, 5 ton an hour at 28% solids. And that's because we're receiving in 5 ton an hour of wet and we're making it a solid to process into the Ctec plant. So I don't know whether that sounds Irish or not. So 5 tonne an hour, 5 tonne an hour of sludge. Now with sludge, I must add, we cannot process pure sludge in a Ctec plant because we haven't got enough BT values. Okay.
Yep.
So the mathematics are, and I have to give you this in proper language, and I apologize. 5 metric ton of sludge plus 400 kilograms of something else. Municipal, a few tires, a bit of plastic, a bit of biomass, something like that, because the BTU values in sludge are traditionally around between sort of 34 and 3700 BTU, and it's not enough to excite the Ctec plant.
All right, we got lots of questions here. Here's should be a quick one, maybe for Chris. I know you don't have any operating plants in the US, but can you share the locations
Yeah,
where wastewater solids are being
yeah,
processed?
I can send you the list of Central Europe, Janine, and
Terrific.
put that out. That's easy.
All right, I can do follow up with that. All right, thanks for that question. Another question, I think you might have, what's the daily capacity of your largest operating system? I think, Peter, you just explained that, and that the size of the, can you
Yeah.
add more units on if you need more?
Oh, absolutely.
Okay.
We have a completely different technology, but we're not going to talk about it today. But that requires 8 Ctec units bolted together. Now, there's a little bit of a trick and a ploy here. When we bolt Ctec plants together, we're only bolting the front ends together. In other words, the gasification chambers. On the rear ends, it doesn't necessarily mean we need too many additional turbines. Okay, because it's all about processing through the front end. So what I'm saying is that what I'm trying to say is that if you bolt 8 plants together, it's not going to be 80 million bucks.
Right.
Yeah, 8 times 10 million.
Okay.
It's not. Far from it, actually.
Here's a question from one of our engineering members. What's the largest system installed? And again, we understand what the unit is, but what's the largest system you have operating?
8 units bolted together, which processes 150 metric ton of unrecycled municipal per annum.
Okay.
And there's more than one of those.
Okay. And how old is the oldest one that's been operating?
Of which, of the Ctec plant?
Yes.
Like 7 or 8 years.
The oldest one's now 9 years.
9 years. Okay. Noel just had a follow-up question about the capacity. You mentioned 18 tons per day of sludge, but is that dry or wet?
Metric.
You use a wet, metric. Yep. Wet.
Well, no. Municipal's wet anyway.
Yep.
So what I'm saying is 18 ton of municipal or 18 ton of, medical. There's always moisture and waste. But from sludge, it's 5 ton per hour. Do your own math.
Here's another question. I think you alluded to this before, and you mentioned about this. What percentage of wastewater solids can you process? Like what total solids percentage can you take in?
Of what product?
Of sludge, wastewater sludges. Did you mention 20% or something?
Well, it usually
No,
comes in
no,
at 28% wet, right? And 72%. I mean, 72%.
Can you process anything that's wetter than that?
Yeah, we're okay down to 20% sludge, 80% moisture. We can process more, but that means the wastewater treatment plants are cheating because they're not doing their job first.
I see. Yeah, you mentioned that before. Yeah.
Yeah.
We should be reducing the moisture content before shipping it off. Here's another question. Is gasification or pyrolysis classified under RCRA? So that's in the US, that's our hazardous waste. Subsections as incinerators. So would they require permits before construction starts under?
Yeah, we
RCRA?
require obviously a building permit and air emissions. And air emissions.
If it was a hazardous, if you were going to be dealing with hazardous waste, you probably need a RCRA permit in the US, just so you know.
Yes.
Yeah.
All right. Here's another good question. This is regarding the mandatory maintenance contract. Is
Yep.
there like $1 per ton operating cost that includes that you have?
No, because we've got no control over whether they turn the plant on or off, whether they feed it bloody 5 ton a day or 18 ton a day. No, that is the cost. I mean, that's probably been raised as a concern from an operating point of view. Okay, and what it
Right.
costs
No,
to
that's coming from a plant
Well,
operator. How much
let's-
does it cost per
let's-
ton?
Let's just expand on that a little bit. Okay, we don't require, it's advised to have 2 staff operating a Ctec plant. Okay, now those staff don't have to have college degrees. They don't need to be engineers or anything like that. They basically just got to be people that turn up because they're really not doing anything. Those 2 staff can easily cope with 5 plants bolted together. Okay, so if you sort of and those staff also don't have to be there 24/7. Okay, because the plant's not really interested if there's anybody there or not, as long as it has feed available, whether that be through a pipe for sludge or a tank for sludge or enough waste in the hopper feed. The plant doesn't need anybody else ever. Okay, even with medical, we've got robotics, so the waste is never touched by human hands. All right, so from an operational point of view, you're talking about 2 staff for 8 hours or 1 for 8, and 2 shifts, and that's it. Your maintenance contract, and then to be fair, there is another cost of about $6,000 a year, and that is for hydrated lime and something carbon. What do you call it? The word just escapes me, because that's in part of our air emissions processing unit. We use hydrated lime, and I just for the life of me can't think of the name of the carbon.
Okay, you'll get it.
Yeah.
Yeah, you're talking 50 cents a kilo and $1 a kilo for the products. It's nothing. But that's about $6,000 a year.
Okay.
So you're going to get change out of, I just pick a figure, $450,000 a year operating cost.
Okay. Thank you. Somebody's asking if you have data on the destruction efficiency for PFAS. I'm assuming you must have something going on with that patent.
Yeah, we do, but until the patent is approved in the US, we're not going to hand that data out.
You're not going to make any claims right now. You can remove a 99.9%. I like that. We'll wait and see. Here's a question from Mark. How do you manage your processed product? Well, I'm not sure what you mean, Mark. I don't know if you want to unmute.
Well, there's only 3 processed products: green electricity, which can either be, it depends on the client. Obviously, if it's for sale, which most of the times it is, it needs to be attached to the other side of the bar so that you can feed the grid, obviously through transformers, because we're producing it we're producing it at 3-phase, so it needs to potentially be converted. The other product we produce is through a whole different technology that we didn't really want to go into, but we have the ability of producing green ammonia, which is extremely safe. We can capture carbon, so that carbon can be sold to your local, vertical farmer or glass house. We don't really recommend it because it's I've been blunt, it's a pain in the ass. It's a lot easier to destroy it and claim the carbon credits. The other product that we obviously have available as a revenue source is the thermal energy. And what happens with that is that you would run it through thermal pipes at 65 degrees Celsius out to your local town hall or sports stadium or wherever the hell it's going to provide all the heat. Or the other trick is we run it through our absorbed chiller unit during the summer periods, and we provide cooling. So in a hospital's a really good example. We heat the hospital during the winter and we cool it during the summer. So those are sort of your three or three of the 4 external revenue generators. So there are 5. One is obviously a tipping fee for product coming in, and then the 4 products going out.
And then the ash, and there's a couple of questions here on the ash,
Yeah.
Peter, because in the
Yeah.
US, again, that RCRA, the Resource Conservation Act, where they identify stuff as hazardous. So you mentioned mercury. So,
Yeah.
and there's a couple
Well, we've
questions
got
here
them-
on the ash. What?
Janine, we've got them completely beaten with the ash because it's sterile. Okay. Now the problem we've got in the States, okay, is that it's legislated, and I understand why. Okay, because generally ash is a real issue. But if, and I say if, we feel like going to the legislators and getting permitted to actually sell the ash, we have numerous cement or concrete companies in Connecticut desperate to take our ash because they're bringing it up from out of state and they're paying a fortune for it. Our problem is we produce such a small quantity, and I'm talking with potential buyers of our technology on this Zoom call. Guys, stick it in the plasma unit and forget it. Stop stressing about it. It's a lot. You're losing a little economically, but from a legislative point of view, it solves all your issues. Destroy it and forget about it. That's my answer.
All right, good answer. Yeah, you might want to just do some testing for metals and stuff, just so you know, the US is going to have
Well, we
some
do
regulations
that.
on
We
that.
do that anyway.
So
We
you
do
have
that.
already have it.
Yeah, because we do actually mine the ash. I mean, there's, if somebody's thrown a computer in their municipal, as an example, and it goes through our system, there's all sorts of interesting things that we want that aren't necessarily huge economics, but it adds up over years.
Yep.
Copper, traces of gold. There's all sorts of interesting stuff in ash. You got no idea what people throw away, I'll tell you.
Yeah.
Absolutely.
Let's see, what do we, all right, so that was that. I think I've covered all of the question. I tried to group some of those other ones together. Anyone else want to unmute and ask questions? Obviously, there was one question about where can we get more information. So if you could get me that,
Yes.
that basic
absolutely.
schematic and a couple and the locations for your European installations, I'll follow up everyone. I'll get you as much more information as I can from these guys. And
Just
I'll
for
send
those
that out
that-
with the recording.
Janine, if you will,
Yes.
just for those that that haven't heard about us before and they're interested in the PFAS side. One of the things is that our footprint's fairly small. In my language, it's 30 meters by 20 meters. In your language, it's 115 by 65. So the plant itself is very small. The plant weighs 65 ton all up. It takes 2 weeks to install and commission on site. And if for some strange reason we had to pull it out, it takes a week. And we just shipped it somewhere else.
So it's modular. It's like you can just
It's
throw it
basically
together on
yes.
site.
Yeah, it's basically
Cool.
16 different modules, Janine. The biggest and the heaviest module is obviously the turbine unit, of which the turbine in the States, we will still be using Siemens because
Okay.
our turbine, we designed it, it's all patented, but they manufacture it on our behalf. We do actually buy that directly from Siemens, or we may use Emerson's out of the States as well, just because of the inquiries we've got. I'm not sure we can handle out of Europe. So we'll be manufacturing. That's the other thing. 80% of this plant is and will be manufactured inside the States. And now that allows you at least 30% tax credits, at least. There's a whole lot more, but this is not the platform to go into that. This comes to the, how quick does the Ctec plant pay itself off? I can tell you, if you're processing medical, you guys are going to get your money back in less than 9 months. If you're processing sludge, anywhere between 18 months to 36 months. Municipal, 24 to 36. Okay, so
It's quite the return on investment. Yeah.
yeah, it's pretty cool. So we're obviously quite keen on joint ventures or owner operators out of purely out of greed. Let's be honest.
All right. And there's just a couple of more comments. And again, on the regulation side of things, we know that US EPA is, even though pyrolysis and gasification are not combustion, and they've said that they're going to be regulating pyrolysis and gasification, we expect at some point. So we hope you can hurry up and get in there.
We've got white papers that say we conform to EPA. EPA is not our issue. Our issue is every individual state have their own rules.
True. And California is probably there's some states around here that are pretty tough too.
Yes.
But good luck. Sounds like you're on the right path there. Any more other questions? I'm gonna, like I said, I'll follow up. If I didn't catch one, I will make sure I answer it in the follow-up email there. But I really want to thank Chris and Peter. I know this is a little bit of a different format, but it made for more interesting discussions, I think. And really, we wish you the best. Ctec Energy's growth in the US. We need all the solutions we can get for our biosolids. So I'm definitely cheering you on. But thanks to everyone for joining us today. Our next Lunch and Learn, our next session scheduled for September 22nd. And we're going to continue with this PFAS theme. We're going to hear from NEBRA member ECT2 from Maine about the latest advances in PFAS destruction technologies. And the one in October will be a presentation by a NEBRA member, Madison, Wisconsin Metro Sewerage District, on the importance of proactive customer communications around PFAS. And they'll show us the program they developed, which is outstanding and a great example for the others. So please check out our events page for more information. And I'm always looking for suggestions for future Lunch and Learns. If there's something you really want to learn about, send me an email or give me a call. I appreciate it. And with that, thanks again, Chris and Peter. Thank you everyone for joining us. Have a great Friday and a great weekend.
Thank you, everybody.
Thank you, Janine.
All right. Take care.
Take care.
Bye-bye.